Okay, so on to the, this will be the last video. So Chocolate Box Company, problem 11. Going to make open-topped boxes out of 3 by 13 inch rectangular cardboard by cutting squares out of the corners and folding up the sides. What is the largest volume box it can make this way? Okay, so here's our situation. 3 inches, 3 inches by 13 inches by 13 inches. And we are going to make this rectangle into a box by cutting out squares in the corners, and then we'd essentially fold up these flaps, so these pieces would no longer be in existence. So by folding up these flaps, we would have an open-topped box, and we need to know, well, what size of square do we need to cut out of the corner in order to have the most volume? What is the largest volume box it can make? Okay, so I'm calling this dimension x. So all of these squares have a side length of x. All right, so I guess we want to maximize the volume. All right, so let's describe the volume. Well, the volume of this here open-topped box, that's going to be the length times the width times the height. Well, the length of this box, it's not 13, so careful. That was the original side length. So the original side length of the rectangle was 13. However, when we cut out these corners, we will get 13 minus x as the side length of the open-topped box. So the length is going to be 13 minus 2x. That would be this dimension here. And then this dimension here, as you might anticipate, well, that's going to be 3 subtract off 2x's. All right. Now the height of the box, well, that's going to be, imagine folding in these flaps and recognize the height component is going to be the length of this cut, which is x. Ooh, so that's a nasty one. So this is the volume. Recognize it is only in terms of one variable, x. So let's go ahead and call this v of x. So from here, recognize we have the function, a function, which describes the volume, and that function only is in terms of x. So we can find v prime of x. So recognize in order to find v prime of x, we need to distribute we need to multiply or FOIL these two binomials, and then be sure to distribute this x across the results. So you'll have a nice equation which represents the volume in terms of x. Take the derivative, so find v prime of x and set that equal to 0, and solve for the values of x that make that true. So this volume equation, it should come out as a cubic. So recognize we'll have an x times an x for an x squared multiplied by another x for an x cubed. So the volume equation is going to be a cubic equation, meaning a polynomial where the highest degree is 3. So when we take the derivative, we're going to get a quadratic equation. and then recognize setting a quadratic equation equal to 0. You'll have to factor. If it does not factor, find the quadratic formula and then solve for the values of x that way. So this is going to be well, I can tell you what the leading term is going to be. Negative 2 times negative 2 gives you a positive 4. X by x gives you an x squared times another x for an x cubed. So the volume equation is going to start with a 4x cubed. So your derivative equation is going to look like 12x squared dot dot dot. So this is a quadratic. If you need to solve a quadratic being set equal to 0, factor and then apply the 0 product rule. If it does not factor, go find the quadratic formula and apply the quadratic formula to this quadratic. All right, and that should be enough to get you going and hopefully finish up this homework. If there are any questions, I most certainly can address those on the back end of this assignment. So good luck in solving, and I'll see you soon enough.